Good morning, pilot teachers and students. Good morning, class.
Good morning, Mr. Sarama.
Okay, thank you. You may sit down. Okay. The topic in our last lesson we studied density. Okay, you know that density is the measure of amount of matter or particles per unit or per volume. Okay, that is what we studied in our last lesson, and you have seen how we can measure the density of certain substance. For example, if it is a regular, you just go straight to measure the volume and then you divide that, or get the mass and then you divide by the volume to give you the density. Now, you also measured the density of some substance, especially when they were irregular, meaning that they are not straight. So that is by using displacement method, using water to give you the volume of that object, and that is how you measure the density. Now, in this lesson, we'll be basically going through and then looking at pressure. Okay, that is especially pressure in solids. Now, given one example, if you decide to use a drawing pin and your fingers and you decide to push it into wood, which one of those would you think will go in more quickly? John, which one of those materials would go in? The pin or the fingers would go into the wood?
Pin.
Okay, the pin will go into the wood. Okay, Michael, you tell us, why should the pin go into the wood?
Because the pin has a small surface area and it's applying a lot of when you're pushing the pin onto the wood, you're applying a lot of force into a small surface area.
Okay, very good. So when you are using a pin and a finger, just imagine you are trying to press your fingers on a desk. Right? Simply the finger has a larger surface area. That is why the pressure that you exert would be quite low. But because the pressure that is exerted by the pin is quite high, it can simply go into the wood. That is more similar to knives. If you are using a very blunt knife and also a sharp knife, right? The blunt one will not cut much better. Otherwise, if you decide to use a sharp one, right, you will cut more better than the blunt knife. So that depends on pressure. Okay, that again depends on pressure, because the sharp one has less, it has less surface area. That is why the pressure that is exerted is more higher, while the blunt one has surface area which is quite high, okay, more. That is the reason why it has to have higher or lower pressure. Okay, I will now go through and then give you some information on that, and basically I will go through the explanation. Right, for pilot students, as you're watching, I will go through and then explain to you. Okay, that is an example which was discussed earlier. Right, if you can push a drawing pin into a wood, but you cannot push your fingers into the wood. Right, why is that? Okay. Pilot students, okay, or pilot teachers, you can ask questions why this would happen. Right, and also you'll find that, especially, what is the difference between a sharp knife and also a blunt knife? Now, looking at these two differences, we can now see that the difference exists in the area. Okay, the point of the throwing pin or pin and the sharp knife has a small surface area, and the force acting over a small area gives a large pressure. So small area gives you large pressure. Large area will give you a small pressure. Right, you can go through now for those students. Okay, go through quickly and then copy this information. Okay, I will give you the next later. Shall I ask the students just go through step by step with this one, give them time as well as the others, or should I run through with this one because you have that information already, or no, we'll just go through. That is information as well. Okay, okay. This one we just do it the way you just, okay. Right, I will now go on to the next information. Okay, given by that formula you have pressure, or what is pressure? Right, pressure is the force that is applied per unit area, and it is given by that formula as pressure equals to force over area. Right, force is simply measured in newtons and area is in meters square. Right, that is in SI units. Another unit for pressure is the Pascals. All right, that is after place Pascal. So you use this Pascal or simply PA. Okay. If the force is in Newton and the area is in square meters, then we know that it is now Pascals. Okay. If it is in centimeters, it is not in Pascals. But if it is in Newton per square centimeters, then we can simply call it as a Pascal. Okay, that is a unit of pressure. Right, quickly go through, have that formula. Okay, now to the next information, that is a formula. Okay, once again, the unit of pressure is in Pascals, so Newton per square meters. Right, that is given below. That is simple, that is given. Newton per square meter or kilogram per meter per second square. Or if you decide to have it in dimensional unit, right, meters length time square. Right, I will now give you the some of the examples of where pressure exists. Right, that is a tire that is turning, or if it is stopping, you'll find that the area of contact between the wheels and also the surface of the road will be that is where the pressure will be acting. Okay, so that is at this point. Okay, that is for a car tire. Now others, for example, if you decide to wear this shoe, the pressure will be more higher because the contact points with this surface is quite, the area is quite small. That is why the pressure which is exerted by this will be more higher. Right, this point can even damage floors. If you decide to work in a cement floor, it may spoil this one, spoil the floor. Why? Because the pressure at this point is quite high because of the area. Okay, because of the area. Okay, so that shows you the area of contact. Our next example would be, okay, that is for the same information given. These hills are pressure points. That means they concentrate the wearer's weight into a very small area. That is why it can mark floors. Okay, next is simply the cube. If you have to look at this, you have length, weight. That is how you can measure the area. And then the force is simply the weight of this object. So that is weight equals to mass times acceleration due to gravity. So using this force over the area, you can calculate what pressure this is exerting. For example, if you decide to leave your calculators or let's say the exercise books on the desk, you'll find that, and you can easily measure pressure with that. Okay, simply finding the area of the book and then getting the mass, and then you're calculating the force or the weight using the formula pressure equals to force over area. You can calculate the pressure as well. Right. For this sphere, you will find that these pressure points will be especially at this point. Okay, that is where the pressure will be existing. And right to the activity questions, pilot teachers, you may also ask the students to quickly go through, copy this information. There are basically 5 questions. Question 1 has 6 parts to it. That is A, B, C, D, and E and F. And then you have question 2, which has question 2, 3, 4, and 5. So those are the questions that you will be doing now. Quickly go through. I'll give you some time to copy, and then I'll give you time to do your working out. So pilot teachers, you can now ask your students to go through and then have this information down quickly. All right, to the next information, still on question 1. Who were those people I choose to? Okay, that is question number 2. Quickly copy that information and then I'll give you 3, 4, and 5. All right, that question is quite funny, but anyway. Okay, just include the figures to calculate the pressure. Okay, to the next question, that is question number 3. You have 4 and 5 still to copy. Okay, question 2. Your question 2. Did you do question 2? Yeah, you did question 2. Question 2 and you did question 3. Let's see. Question number 4. Question number 4 you will have to, and you do question 5. Same on. Okay. Here is question number 4. Question number 4.
Question 1 there, 2. Question 6. Question 1. 2, question 6. See, so this should be A up to S.
A up to F. So how many is that? 6 of them. I didn't know that I put 6 of them. There was 6. Question 1 you have C there, 2 C's. Okay, I'll fix it up. Okay, so we have only 5. 1, 2, 1, 2, 3. Okay, 3 of them. 1, 2, 3, 4. 4 of the rows. Okay, the final question. That is the final question. An average wind pressure on the wound is 100 pascals. And then you have, if the area is 6 meters square, what is the total force acting on that wall? So this time it is asking you to calculate the force. All right, you finish copying, quickly go through and then do those questions. You get ready, because in a short while I'll call you to come. Yeah? Rolling. Okay. Sending you. You use the mic, answer the question, pass it over there. Okay, she will use it and then pass it this way. Okay. When you answer, you pass the mic this way. Okay. Question 2 and 3. Question 2 and 3. Okay. You get ready. Sorry. Not question 2 and 3, question 4 and 5. Okay. 2 and 3. Question 2 and 3. Is the first question and both up the sulhab answering. all basana so and say okay is the number question 2 3 4 na 5 yeah mo come say that. Okay, finally I will be asking you students to come up quickly, and for the first question I'll be asking students to give you explanation of those. For the other questions, that is question 2, 3, 4, and 5, right, you can come up and then show your working out. All right, that is, those are the questions. Let's have our first answer from Ruli.
This question reads, stiletto heels are more likely to mark flaws. This because the wearer's weight or the force exerted by the wearer is concentrated in a small area, therefore the pressure exerted is great, causing marks on the floor.
Okay, very good. So you just heard his answer. For pilot students, the pressure is quite high because the wearer is concentrating a large amount of force especially on a small area. Okay, good. We'll go on to the second question.
For the second question, Eskimos wear racket-type shoes so as to increase the surface area, which the force acting over the increased surface area gives a small pressure, and that makes it easier for them to walk on ice or snow.
Okay, good. We don't know why the Eskimos decided to use these shoes, but anyway, because if they wear something like a stiletto heel, right, they will simply sink into the ice. So probably that is the reason why they have to wear these shoes, because it can make it easy for them to travel. Okay, we'll have the next question that is C.
It would be more painful to walk on pebbles than on sand because the surface area of the pebbles is larger than less than that of sand.
Okay, the surface area of the pebbles is more or less. Okay, very good. So that is the reason why if you have to walk on sand, you'll be more comfortable. But if you have to walk on pebbles, you'll find quite painful, okay, because of the area.
It helps to hold a puzzle by a string because the string has a small surface area which gives off a large pressure onto the hand.
Okay, good.
Camels' feet have large surface areas which reduces the pressure on the sand, thus reducing the amount of sinking.
Okay, that is for question D. Good. Okay, we'll have the last question.
The physics teacher is not hurting himself because the teacher has spread his body out through so that it is supported by a lot of nails. The area of nails supporting him is large enough for it not to hurt him.
Okay. Right, just imagine if you were to sleep on a pair of nails. Because there are lots of nails, that means it increases the surface area. That is why the teacher is not hurt. Okay, we'll have question number 2 and 3 on the board. You can come up at the same time so you're working out. One explains first and then the other one, okay? Question 4 and 5, you get ready. Okay. Just clean that piece off. There. Okay, you do it next to him. kira the your side is there. One of you go, then two. Okay, wait. He will explain first and then. Okay, give me that mic.
To find the pressure, use the formula. Force, pressure equals force over area. The force is 800 newtons and the area is 4 cubic centimeter. To change these 2 meters, I multiplied by, divide by 100, came up to 0.04, and then square it, came up to 0.016 square meter over 800 newtons, and then came up to the answer 500,000 newtons per square meter, or 500,000 pascals.
Question number 4.
Okay, in order to
So
change
question number 4.
1,000 centimeters
Question
to
four. Yeah.
meters, I multiply by 100 and divide it by 1,000 and came up with 0.1.
You didn't write it
The
down.
pressure is equals to force on area. Pressure equals 8,000 on 0.1 here.
Copy question number 4.
I came up with 80,000 newtons meter squared.
Did you do question 4? Question 4. Okay, so we'll have a look at this. Let's see how this one is done. Okay, we have this. Okay, what is the answer when you calculate this way? It's 18. Okay, what is the answer? 80. Right, 2 million pascals. Right, that is the answer. So this one is okay, but probably you need to change from around here. Okay, so the answer in here would be, right, 2 million. All right, for that question, let's have a look at the answer. Okay, the pressure is okay times one, two, three, four, five, six, seven. Okay, that one is correct. All right, we'll have the last two questions. Last two questions. Okay, anyway, you have copied that information. That is question number 4. Right, you find that concrete block measuring 0.5 times 1 times 2 has a measure of 2,600 kilogram. Okay, what is the maximum pressure it can exert on the ground? Now, that is for question number 4. The question number 5 is you have a wall that is in place, and then you have a wind pressure of about 1,100 pascals. Right, if the area is 6 cubic meters, what is the total force that is acting? Right, what is the total force that is acting on this wall? So go through and then finish these questions. In our next lesson, probably I will discuss on how you can get this answer. But in the meantime, I'll just give you the answers to those 3 questions. You can go out or go and then do your own working out, solve that, and then come up with the answers. Right? So the answers to those questions, right, you have a first one, which is about 2,000 pascals, and then you have 80,000, 52,000, and 600 newtons. All right, those are the answers to those questions. If you find any difficulties, especially for those pilot teachers, you can, rather the students, you can always ask your teachers on how this is obtained or these answers are obtained. Right. Now, to quickly recap on what we went through, pressure is the force that is exerted per unit area. A larger pressure will be determined by the small area. Okay, if there is a small area, pressure will be quite large. If there is a large surface area, the pressure will be quite small. So that is the main points that you should now consider. Right, so that brings us to the end of the lesson, and our keyword for today will be pressure. You can stand up now. Once again, good afternoon, pilot teachers and students, and good afternoon, class. Right, thank you.